In this video, we will discuss about a specific type of quadrilaterals called as parallelograms. So we'll talk about parallelograms, what is a parallelogram, and we will discuss some of the properties of parallelograms. First of all, what is a quadrilateral? As the name suggests, quad means four. So a quadrilateral is a figure or a polygon that has four sides, four angles, and four vertices. So if you look at all these figures here, these are all quadrilaterals. They have four sides. That's the first side, side number 2, side 3, side 4. It has four angles. So there's an angle here, there's an angle over here between these two sides, the third angle between these two sides, and the fourth angle is here. Four angles and four vertices. So that's vertex number 1, vertex number 2, vertex number 3, vertex number 4. Similarly, all these figures are quadrilaterals, which means they have four sides, four angles, and four vertices. And some of the quadrilaterals which we are familiar with, like the square and rectangle, okay, these are also quadrilaterals because they have four sides, four vertices, and four angles. Okay, so square and rectangle is a quadrilateral that we are all very familiar with. Now, what is a parallelogram? A parallelogram is a quadrilateral in which both the pairs of opposite sides are parallel. So if you look at this side here, this side and this side, they are parallel to each other, and the side at the bottom and the top are also parallel to each other. This is also another example of a parallelogram. The side on the left and the right are parallel. The side at the bottom and the top are parallel. Similarly here, the top and bottom sides are parallel, and the left and right sides are parallel. So a parallelogram is also a quadrilateral because it has four sides, four angles, and four vertices. But the condition is that both the pairs of the opposite sides of the parallelogram are parallel to each other. Okay, so that's the definition of a parallelogram. Next, we will see some properties of a parallelogram in the form of theorems. We will state each property in the form of a theorem. However, we will not proceed with the proofs of these theorems. The proofs we will do in the next video, step by step. But in this video, I'm only going to be talking about the properties. So we have an idea of all the properties of the parallelogram, and thereafter we can go ahead with proving those properties using the ideas that we have developed in our topics on lines and angles and triangles and so on, congruent triangles and so on. Okay, so the first property of a parallelogram, which we call as theorem number 1, is that the diagonal line of a parallelogram divides the parallelogram into two congruent triangles. So we have seen what is the meaning of congruent triangles in the previous chapter. So if we put a diagonal line inside the parallelogram, it divides it into two triangles, and these two triangles are congruent to each other. So in our parallelogram ABCD, if we draw a diagonal line AC, it forms two triangles. ABC is one triangle and ACD is the other triangle. And what this the first property states that these two triangles ABC and the triangle ACD are congruent to each other. Similarly, if we had drawn the diagonal between the other two vertices, that is D and B, then it creates two triangles again, ABD and triangle DBC, and both these triangles are also congruent to each other. So this is our first property of a parallelogram, which is stated in the form of a theorem, which we denote as theorem number 1. The next property of a parallelogram is that the opposite sides of the parallelogram are equal. So if we have a parallelogram ABCD, then the sides which are opposite to each other are equal in length. That means the side AD is equal to the side BC, and similarly the side AB is equal to the side DC. So I marked the equal sides with the dashes. So the side with a single dash, they are equal, and the sides with the double dash, they are also equal to each other. So AB is equal to DC and AD is equal to BC. So that's our theorem number 2, which we state as that in a parallelogram, opposite sides are equal. The converse of theorem 2 is called as theorem number 3, and as you know, the converse of a theorem means whatever is the given that becomes the result, and whatever is the result that becomes the given. So here in theorem 2 it says in a parallelogram opposite sides are equal, but the converse is if the pair of opposite sides in a quadrilateral is equal, then it is a parallelogram. So if the opposite sides of a quadrilateral are having equal length, then the quadrilateral becomes a parallelogram. So it is a parallelogram. So if we see here in the first slide, the sides lengths or the opposite sides do not have the same length, so it's not a parallelogram. Even here, if you look at the opposite sides, their lengths are different, so they are not parallelograms. But when the sides become of the same length, like in this case AD and BC, they are the same length, and AB and DC, they are the same length. If we have a quadrilateral in which the opposite sides of it are of equal length, then the quadrilateral is a parallelogram. Okay, again we will be doing these proofs later on in the next video, but for now just remember that in a parallelogram opposite sides are equal, or conversely if the opposite sides of a quadrilateral are equal, then that quadrilateral is a parallelogram. The next property is that in the parallelogram opposite angles are equal. So if you look at the vertices, the angles formed at the opposite vertices are equal. So angle A is equal to angle C, and angle D is equal to angle B. So opposite angles are equal in a parallelogram, or the converse of this property is that if the opposite pair of angles in a quadrilateral are equal, then it becomes a parallelogram. So that's the converse of theorem 4, which we denoted as theorem number 5. So what we need to remember is that opposite angles are equal, and the previous property stated that opposite sides are equal. Okay, so that's the theorem number 4 and theorem number 5. Again, we will be doing the proofs for all these properties in the subsequent videos. The next property of a parallelogram is that when we draw both the diagonals of the parallelogram, they bisect each other. That means the point of intersection of the two diagonals divides the two diagonals into two equal parts. So that means if we draw the diagonal AC and the diagonal BD, they both intersect at the point O, and if this quadrilateral is a parallelogram, then OA will be equal to OC and OD will be equal to OB. So the lengths which are equal, I have marked with a single dash and double dash respectively. So OA is equal to OC and OD is equal to OB. Again, this is true only if the quadrilateral is a parallelogram. The diagonals of a parallelogram bisect each other. This does not apply for all quadrilaterals. It applies only to parallelograms. The converse of this property is stated as if the diagonals bisect each other, then the quadrilateral becomes a parallelogram. Okay, so what we need to remember here is that when we have a parallelogram, the diagonals bisect each other. That means the diagonals meet at a point which divides the diagonals into two equal parts. So as I said here, OA will be equal to OC and OB will be equal to OD. Okay, so that's theorem number 6 and 7. Again, these are converses of each other. So we have these basic properties of the parallelograms, which we will use in solving problems as we go ahead. Okay, now before I wind up this video, I want to show some common parallelograms that we are all familiar with. The first common parallelogram that we are all familiar with is the rectangle. The rectangle is also a parallelogram. That means opposite sides are parallel. So the bottom side and the top side are parallel to each other. The left side and the right side are also parallel to each other. But it has a specific property that all the angles are 90 degrees. So this angle here is 90 degrees. This angle here is 90 degrees. This angle here is 90 degrees. And this angle here is also 90 degrees. Now, When we talk about a rectangle, it is sufficient to state that one of the angles of the parallelogram is 90 degrees. If one of the angles of a parallelogram is 90 degrees, then automatically it becomes a rectangle, because then we will do this proof later on in subsequent videos. We will show that if one of the angles is 90 degrees and the opposite sides are parallel, then automatically the other angles will also become 90 degrees. And that is one of the properties wherein the parallelogram in which one of the angles is 90 degrees is in fact a rectangle. Similarly, another common parallelogram that we are all familiar with is a square. Of course, the square, we know that all sides are equal, so they are not just parallel, but they are also equal. All the four sides are equal. Unlike in a rectangle, the opposite sides are equal, but in a square, of course, the opposite sides are equal, but all the four sides are also equal. The left hand side and the right hand side is equal. The bottom side and the top side are equal, and the bottom and top side's length is equal to the left and right hand side's length. Okay, so that's a square. And of course, in a square, all the angles are also 90 degrees. So the angle between any two sides is 90 degrees in a square. So the difference between square and rectangle is that both are parallelograms in which all the angles are 90 degrees, but in square we have the additional condition that all the sides are of equal length. Similarly, we have another figure which is called as a rhombus, in which all the sides are equal, but the angles are not necessarily 90 degrees. So the angles inside between any two sides, they are some other angle other than 90 degrees. If all the angles are 90 degrees, then it becomes a square, but the lengths of all the sides are the same. So that means all these lengths are same. Similarly, in a square, all the four sides have the same length, but in a rectangle, only the opposite sides have the same length. So here this is a different length, and the opposite side also has a same length, but the left side and right side length differs from the top and bottom side lengths. Okay, so these are all common parallelograms that we are all familiar with. Okay, so we have seen in this video some properties of parallelograms. The most important is the first one is, of course, all of them are important. The first property is that the diagonal line of a parallelogram divides it into two congruent triangles. The second property is that the opposite sides are equal. The third property is that the opposite angles are equal. And the fourth property is that the diagonals of a parallelogram bisect each other. And of course, to each of these properties, we have the converse as well. We will be proving these properties one by one in subsequent videos. Okay, and we have also seen some common parallelograms which we are familiar with, which is a rectangle, a square, and a rhombus.